Welcome to today's Explainer. We are skipping the pleasantries right now because we're dropping straight into one of the most terrifying and frankly miraculous scenarios in modern aviation history. Just imagine this for a second. You're suspended 7 miles up, right over the pitch-black Atlantic Ocean in the dead of night. You're chilling inside a state-of-the-art aircraft, and suddenly, the unthinkable happens. Total engine failure. Based on our source material, we're going to unpack the exact timeline and the sheer physics behind Air Transat Flight 236. Seriously, how do you land a 150-ton commercial airliner over the middle of the ocean with absolutely zero fuel? I mean, it sounds exactly like the setup to a Hollywood disaster movie, right? But this was a very real, incredibly high-stakes engineering and aerodynamic puzzle. Today, we're looking at the exact mechanics, the rapid-fire split-second decisions, and the honestly unexplainable errors that made the impossible entirely possible. Okay, so let's set the scene here. August 23rd, 2001. A practically brand new 2-year-old Airbus A330 is geared up for a transatlantic hop from Toronto over to Lisbon. You've got 306 souls on board, 293 passengers, and 13 crew members. And up front, no rookies. The flight is commanded by 48-year-old Captain Robert Piché, who brings a staggering 16,000 hours of flight experience to the cockpit, sitting right alongside First Officer Dirk de Jager. In short, there was absolutely no lack of experience at the controls and zero known faults with this incredibly advanced plane. Before takeoff, they loaded up 48 metric tons of fuel. Now, to put that into perspective, for a standard 7-hour nonstop flight across the Atlantic, 48 tons is a massive amount. It was way more than enough to safely make the crossing and handle any normal weather deviations. Everything was completely 100% by the book. Flash forward about 4 hours into the journey, and they've hit the sweet spot. The aircraft is cruising along at 39,000 feet, smack in the middle of the pitch-black Atlantic. The autopilot is doing the heavy lifting, which, is completely normal for this phase of a long-haul flight. Back in the cabin, it's the middle of the night, most of the passengers are fast asleep. It's the absolute picture of aviation calm. But as you can probably guess, that calm was about to shatter. Section 1. The invisible fuel leak. Boom, 1 a.m. Canadian time, the very first bizarre warning hits the cockpit. The pilots start noticing some really abnormal readings coming from engine number 2. That's the right engine. We're talking high oil pressure, low oil quantity, and unusually low oil temperature. And the manuals, they literally couldn't explain it. The pilots even radioed maintenance back in Canada, but the engineers were totally stumped. They just said, hey, monitor the situation. But the real danger wasn't the oil at all. It was something entirely invisible to them. About 30 minutes later, a brand new advisory pops up, a massive fuel imbalance warning. You see, commercial airliners distribute fuel equally across both wings to maintain aerodynamic balance. But suddenly, the fuel level in the right wing was dropping way lower than the left wing. Now, here's the thing. Fuel imbalances aren't usually a death sentence. They can generally be sorted out right there mid-flight. So, following standard protocol, the captain detects the imbalance and opens what's called the cross-feed valve. The goal here is pretty simple. Transfer fuel from the heavier left wing over to the lighter right wing to stabilize the plane. But here is the absolute tragedy of this specific step. The pilots were completely unaware that by opening this valve, they were accidentally pumping their remaining good fuel directly into a massive, catastrophic leak in that right engine. Within 10 minutes, the situation goes off the rails. Low fuel warnings start blaring. The math is suddenly terrifying. They are losing 1 ton of fuel every 5 minutes. Let that sink in. They had less than 7 tons of fuel remaining, just 6% of their total capacity. Being out in the dead center of the Atlantic Ocean meant diversion options were practically zero. Their one and only hope was Lajas Field on Terceira Island in the Azores, a Portuguese territory about 240 kilometers away. But they only had 25 minutes of fuel left. Section 2. Engines out over the Atlantic. Okay, so things escalate from critical to catastrophic in a heartbeat. With 240 kilometers still to go, the right engine catches fire and just dies. Panic immediately sweeps through the waking cabin. They are down to just 4.5 tons of fuel and a single engine, which, by the way, isn't enough thrust to maintain their cruising altitude. So the plane begins to descend. During this drop, maintenance actually radios Captain Piché and instructs him to drop down to 20,000 feet to visually check for the leak, but Piché, he flatly refuses. He knew that if this fuel leak was real, giving up altitude meant giving up their only remaining asset, glide distance. And by insisting on staying as high as possible for as long as possible, he literally saved their lives. Because shortly after that, the left engine burned through its remaining fuel, sputtered, and died completely. When both engines die on an airliner, you don't just lose thrust, you lose electrical power. This massive A330 plunges into total darkness. But thankfully, modern aviation has a brilliant failsafe, the ram air turbine, or the RAT. Think of it as basically a little emergency windmill that automatically drops out from the belly of the aircraft. As the heavy plane glides, the rushing wind spins this RAT, generating just enough raw electricity to keep the absolute most essential cockpit instruments alive. Without this, the pilots would have been flying completely blind in the dark. So at 240 kilometers out, they are effectively an unpowered glider. By the time they reach 120 kilometers out, the plane is plummeting at a terrifying rate of 2,000 feet per minute. Back in the cabin, the crew is frantically prepping passengers for a potential ditching in the freezing ocean, a nightmare scenario with an incredibly low survival rate. But they finally spot the island at 15 kilometers out. Huge relief, right? Well, actually, now they have the exact opposite problem. They are at 13,000 feet. For a normal controlled approach at this distance, they should be down at 3,000 feet. Section 3. The impossible dead stick landing. So a dead stick landing means landing a plane completely without engine power. The plane is dangerously high. If Captain Piché simply points the nose down to reach that runway, this massive aircraft is going to build up so much lethal speed that a violent crash landing would be inevitable. He has exactly one chance: no engines to circle back and try again, and way too much altitude. So to burn off that altitude without gaining distance to the runway, the captain violently banks the massive airliner into a full 360-degree turn. This dizzying maneuver drops them to 5,000 feet. But it's not enough. They're still too high. So he lines up with the runway and executes a series of sharp S-turns, literally weaving back and forth in the sky to delay their arrival and bleed off even more altitude. And remember, all of this is being done using manual pitch control. No computer assistance, just relying purely on the pilot's raw physical feel for the aircraft. Normally, a landing uses wing flaps to create drag and engine reverse thrust to slow down. Flight 236 had absolutely no engines to do this. They came in incredibly hard and incredibly fast. The touchdown was incredibly violent. Boom! 8 of the 12 main tires instantly burst upon impact. The immense friction caused the landing gear to literally catch fire as the plane desperately skidded down the tarmac. But it stopped. The ground crew instantly rushed in and extinguished the fire. Against all odds, every single one of the 306 people on board survived. They had just pulled off the longest unpowered glide by a passenger plane in aviation history. Section 4. Why did this happen? Once the adrenaline faded, the massive investigation kicked off because a 2-year-old, state-of-the-art aircraft doesn't just bleed out 48 tons of fuel by accident. The investigation led far away from the Azores all the way back to a maintenance hangar in Toronto. And guys, the sheer mundanity of the root cause is just staggering. It wasn't a complex software glitch. It wasn't a catastrophic bird strike. Before takeoff in Toronto, the maintenance crew had changed a part on the right engine. But they used a part designed for a completely different engine model. Because the part didn't fit properly, it vibrated violently throughout the flight. And over those 4 hours, that metal vibration slowly sawed into a nearby fuel line until it burst wide open, creating the massive leak. A totally simple, entirely preventable maintenance error nearly doomed 306 people. The legacy of Flight 236 is profound. Following the intense investigation, Airbus completely overhauled their systems. They installed brand new in-flight fuel leak warnings that specifically alert pilots to this exact scenario, so nobody ever accidentally cross-feeds fuel into a leak again. And rightfully so, 1 year later, Captain Robert Piché and First Officer Dirk Jager were awarded the Superior Airmanship Award for pulling off what is widely considered the most incredible dead stick landing in commercial aviation history. Ultimately, the story of Flight 236 is a massive testament to human skill overriding mechanical disaster. It completely changed aviation safety protocols forever. But it definitely leaves us with a lingering, maybe slightly nerve-wracking question to ponder today. If a single mismatched, loose-fitting piece of metal could silently drain a massive airliner of its lifeblood, how many single points of failure are flying safely above us right now, just waiting for the wrong vibration? Thanks so much for joining me on today's Explainer. Keep questioning, keep learning, and I'll catch you in the next one.